So I have R to be a region bounded by this function y equals 1 over x, the x-axis, and these two lines. So I want to revolve it. So the first thing I want to know is find the volume. So the volume is my R here is y, which is x to the negative 1. So my volume is pi times integral from 1 to b of r squared, which is x to the negative 2 dx, which is pi times negative x to the negative 1 from 1 to b, which is negative pi times 1 over b minus 1. Okay, b, I have to find the surface area. So again, r is, we know r is x to the negative 1. I know y prime is negative x to the negative 2. If I square that, it's x to the negative 4. I can add 1. So I have 1 plus 1 over x to the 4th. I'm going to rewrite that as 1 over x to the 4th times x to the 4th plus 1. And I need the square root of that. I take the square root of that. It's 1 over x squared times x to the 4th plus 1 to the 1/2. So now I know that my surface area is 2 pi, the integral from 1 to b of 1 over x times 1 over x squared times x to the 4th plus 1 to the 1/2 dx, or 2 pi times integral from 1 to b of 1 over x cubed times x to the 4th plus 1 to the 1/2 dx. Okay, C asks me to show that the volume as b goes to infinity, that the volume has a limit. So I want to know the limit if b goes to infinity of negative pi times 1 over b minus 1. Well, as b goes to infinity, this is going to go to 0, so this is going to go to pi. So it does have a limit. Okay, then it says to show that the surface area goes to infinity. So I have inside the radical I have x to the 4th plus 1 to the 1/2 over x cubed. Now I know that that is going to be greater than x to the 4th to the 1/2 over x cubed, which is the same as 1 over x, which I know is greater than 0. So I can say that s is greater than the integral from 1 to b of dx over x, because I know that we went all the way down to its 1 over x. Okay, and that equals the natural log of x, and from 1 to b, which is the natural log of b minus the natural log of 1, which is the natural log of b. As b goes to infinity, the natural log of b also goes to infinity, and since the surface area is greater than this integral, we know the surface area also goes to infinity.